Okay, so what I'm going to do here is instead of going through a long lesson and then having you try these on your own, I'm basically going to work these all out. But I recommend that you attempt some of these on your own to see how it is. A lot of these graphs we can do using our graphing calculator, and I'll have my graphing calculator out. But uh, we're going to be able to go through these, and we're going to look at a new thing here. If you read the directions at the top, it says find the vertical asymptotes, horizontal asymptotes, domain and range. We're able to do that already. Identify any holes, i.e. discontinuity. We actually get holes in graphs, and I'll show you how that works in a second. And then we'll use our graphing calculator where needed. Let's look at this first one. Okay, so we have this function. Now this is not a function that's in the same form of the functions we looked at yesterday. If you remember the functions from yesterday, they looked like this. Y equals a over x minus h plus k. So number 3 looks a lot more like that, okay? But number 1 doesn't, all right? So number 1, right off the bat, I'm going to tell you, does not have a vertical asymptote. It does not have a horizontal asymptote. You won't get asymptotes unless the power of x in the denominator is bigger than the power of x in the numerator. And right now I actually have x times x, because if I were to distribute this, I would get x squared in the numerator. So the power in the numerator is actually bigger than the power in the denominator. Okay? So because of that, I have no asymptotes. So I'm just going to put the empty set for both of these, because there are no asymptotes. All right? Now, this part here, x plus 3, x plus 3, I could actually take a line through it and cancel those out and just get the graph y equals x minus 4. Okay? And that's actually what this graph is going to look like. It's going to look like y equals x minus 4. If I were to put this whole thing in my calculator and graph it, I'll get y equals x minus 4. Okay? But I can't ignore the fact that this was here. And I can't ignore the fact that I'm not allowed to have 0 in the denominator. So x can still not equal negative 3, because it's, remember, x minus h, it's the opposite. So x cannot equal negative 3. Now that's going to affect my range as well. And I'm going to show you how to kind of find out what that should be. If I were to graph this function, and let's say I put this function here, y equals, and I need to put the entire numerator in parentheses like we did before, so x minus 4 times x plus 3. And then I'm also going to, well, I wonder if that's better with the light off. And that actually is. We'll leave the light off. X minus 4, x plus 3. Okay, and I'm going to divide that by, and the whole denominator needs to go in parentheses, x plus 3. Okay, if I look at the graph, it's going to look exactly like the graph of y equals x minus 4. Okay, the only thing about it is it doesn't have, if you notice here, if it doesn't have at negative 3, it doesn't have a value for y. Okay, well, there's a value that y is not allowed to equal as well. If I were to graph just y equals x minus 4, so I'm removing these two and graphing this, okay, that line looks identical. But when I go to the table, it gives me a value for negative 3. Well, the value that's associated with it, the y-coordinate, is the value that y is not allowed to equal in our function. Y is not allowed to equal negative 7. So our whole comes at a point, negative 3, negative 7. And what it is our graph looks like this. But right here at negative 3, negative 7, there's just a little hole in the graph. Now when we draw that, we'll make it look more exaggerated, but that's how that works. Okay? Now this second one I think is pretty easy. Okay, 1, there's nothing we can cancel out, so there's no holes. Okay? You can write none. I'm just writing n/a, which means not applicable. Okay? Our vertical asymptote, remember, x is the opposite of whatever this number is. Our horizontal asymptote, okay, y equals 0. Remember, because it's plus k. Our domain, x cannot equal negative 1, and our range, y cannot equal 0. All right? That one was pretty easy. We're done with that. That was the same as yesterday. Okay? Number 5, we're not so lucky. Okay? Number 5, the bottom can be factored. And if you guys don't remember, we had the difference of two squares, a squared minus b squared. And the difference of two squares factors into a minus b times a plus b. Well, this is x squared minus 1 squared. 1 squared is 1. So this is the same as 5 minus x over x minus 1 times x plus 1. Now, unfortunately, I did all that work for nothing because there's nothing that can cancel out with the top and bottom. But I need to know how to do that for future problems. Okay? So there's nothing I can cancel out. There's nothing I can do about that. However, this does tell me a couple things. One, it's going to tell me what my values of my function are not allowed to equal. Okay. Two, it's going to tell me where some important points are, like some asymptotes. All right. So let's look at this graph in our calculator. So let's put it in parentheses. Let's do y equals, and I'm going to clear this out. The numerator needs to go in parentheses, 5 minus x. And the entire denominator needs to go in parentheses. I'm going to put in the non-factored form just because it's easier. If I put in the factored form, it would look the same. Okay, so I'm going to put in x squared minus 1, close my parentheses. Okay, so that graph looks right. Press graph, and now I look at it. It looks like I have multiple asymptotes here. So if you look, it shoots up and down here, it shoots up and down here. Got a little curve in here. This is like a really weird little graph. Well, it's because I do have multiple asymptotes. I have a vertical asymptote at x equals -1 and at x equals 1. Okay? Because x is not allowed to equal either of those. Okay? So my vertical asymptote, x equals -1 and x equals 1. My horizontal asymptote, if I look at this, if I can notice it here, it's right at the line y equals 0, and that makes sense because there's nothing being added or subtracting at the end. My domain, x is not allowed to equal -1, and x is not allowed to equal 1. Range, I guess we don't have to put that here because it's not listed. So we'll skip that. Holes, there are none. And the reason there are no holes is there was nothing that could cancel out like number 1. Okay? If I look at number 7, I do have something that can cancel out on top and bottom, the x's. Okay? The x's can cancel out on top and bottom. That gives me a hole at 0. Now, I don't know what that y-coordinate is, but I'm going to find that out. Okay? This, if these two cancel out, is the same as 1 over x minus 1, which would make my vertical asymptote x equals 1, my horizontal asymptote y equals 0, my domain x is not allowed to equal 1, but x is also not allowed to equal 0. The reason x can't equal 0, if I put 0 in there, I got a 0 there. And that's why there's a hole in my graph there. My range, y is not allowed to equal 0, but y is also not allowed to equal whatever this value is in the hole. And how I'm going to figure that out is using this good old calculator. Okay? I'm going to put the graph of y equals 1 over x minus 1 in my calculator. Okay? If I graph that, this is exactly what this graph will look like. The only difference is it doesn't have the hole there. You can see the asymptote where the line's going up and down, but it doesn't have the hole. Okay? So the hole would be at 0. So if we go to our table, the value at 0 is -1. -1. That's the value that y is not allowed to equal. Okay? So that takes care of all of that. All right. So moving right along, number 9, again, x minus 2 will cancel out. All right. So we are going to have a hole in our graph. And the hole is going to happen at the point x equals 2. And we'll figure out the y-coordinate from the graph of when we remove those two values. Our vertical asymptote, x equals -2. Our horizontal asymptote, y equals 0, because nothing was added or subtracted at the end. Our domain, x cannot equal -2, but x cannot equal 2 as well. Our range, y cannot equal 0, and we're going to figure out what y is not allowed to equal when we fill in this, when we find out where this hole is. Okay. So if I graph y equals 1 over x plus 2, And again, we have our vertical asymptote, we have our horizontal asymptote. If you have the nice new calculators, they don't put this silly line in here. The old ones do because of the way the program's written. But if I look at my table at x equals 2, I have the value of 0.25. That's also 1/4. You can put 0.25 if you want. You can put 1/4. I'm going with 1/4. You guys don't like fractions, so you're probably going with something like 0.25. Okay? So that's where that graph is, and that's how that looks. All right? So that takes care of number 9. Now let's look at number 11. Okay? This can factor into x minus 5, x plus 5, right? But that won't help me, so I'm not going to factor it. I'm not going to waste my time. Vertical asymptote, I have one at x equals 5. Horizontal asymptote, nothing's being added, so this is y is equal to 0. Oh, I'm sorry. I'm completely incorrect here. Let me cross these out. My horizontal asymptote, sorry, I messed that up. When the value x squared over x is bigger, in this case, and nothing can be removed, whereas nothing can be removed, my x plus 5, my x minus 5. If I looked back at number 1, I could remove that 3. Nothing can be removed here. I actually still have a vertical asymptote at x equals 4. What I don't have is I don't have a horizontal asymptote. Okay? So I'm sorry about that. I still can't have 4 on bottom, so I'm still going to have that vertical asymptote. So my domain x can still not equal 4. My range is actually all real numbers, and I have no holes, so it's none. Or you can put NA or whatever you want to put. Okay? Sorry about the confusion on that one. But again, if x squared is bigger than, if the power in the top is bigger than the power in the bottom, you will have no horizontal asymptotes. The reason we had a vertical asymptote here and not in number 1 is because in number 1 the x plus 3 kind of cancels out, and here we have nothing that can cancel out. Okay? So that's why that works that way. All right. Number 13. Now the nice thing about number 13 looks at like what we did yesterday. So I know that there are not going to be any holes. I also know that I've got a vertical asymptote at x equals 6. I have a horizontal asymptote at y equals 0. And again, that's because there's nothing being added or subtracted at the end. X cannot equal 6, and y cannot equal 0 is my domain and range. So I'm going to pick 2 values around 6 to get my graph. So my 2 values smaller than 6, 4 and 5. Remember, at 6 I have an asymptote, and I'll use 7 and 8 as well. Okay. Now I can plug this in my calculator and get my values, but I'm just going to go ahead and do this in my head. So this is -1, okay, and this is -2, and then the other ones are 2 and 1. Okay, and you can get that from your calculator. I just did it real quick. So x equals 6 is my asymptote, so it's going to kind of dotted line here. Y equals 0 is my other asymptote. Dotted line there. Okay. So now I'm going to plot those points. 4, -1, 5, -2. And the graph, if you look at it in your calculator, just gets really close to this and really close to this without ever touching. And then I've got 7, 2, 8, 1, kind of comes down here and shoots off that way. I'm not going to have enough room, so I'll just leave it like that. So that's what that graph looks like. Okay? So no big deal there. That's just like yesterday. That's the easy stuff. This next one's a little bit harder. And the next one, we can actually factor the top and the bottom. The bottom, hopefully, you're recognizing now that we have the difference of squares. That's x minus 4 times x plus 4. In the top, we can factor out the greatest common factor, which is 2, and we're left with x minus 4. Now we have 2 things that can be canceled out, x minus 4 and the x minus 4. That means that there is going to be a hole at 4. Vertical asymptote at x equals -4. Horizontal asymptote, nothing's being added to the end, so it's y equals 0. my domain, okay, x cannot equal -4, and I'm going to put a comma here, or 4. And y is not allowed to equal 0, and we're going to find out what that other value is when we plug this into our calculator. Now I'm going to remove this, and when I put it in my calculator, I'm just going to put it in as y equals 2 over x plus 4, because that's what the graph will look like, 2 over parentheses x plus 4. So that will tell me where my hole is, and I'll show you how we're going to put the hole in the graph. Okay, so you can see I've got my asymptote there, I've got everything else. So now we're going to look at the table, okay, and we're going to look at the values. All right, so we know at -4 we have an error, so we've got -6, -1, -5, -2. I know I don't have a value for -4, so I'll use -3, 2, -2, 1, and then we have a hole. We have a hole way down at x equals 4. So at x equals 4 and 0.25, and I'm going to circle this because this is my hole. Okay? So 4, comma, 0.25, and that's what y is also not allowed to equal. All right? So there's a lot of information there. So if you need to rewind it, rewind it. If you need to listen to it again, listen to it again. Okay? So vertical asymptote, x equals -4, 1, 2, 3, 4. Here we go. Here's my vertical asymptote. Horizontal asymptote, y equals 0. Okay. Points, -6, -1, -5, 2. This graph will look like this. -3, 2, -3, 2, -2, 1. And then we have this hole. And here's how we put the hole. We put a real little circle with an open circle. See how it's kind of open there? So we're going to draw this line down. We're going to cross through it. And we're going to get down to this hole. And we're going to keep it open. So I'm not going to draw a line through the hole. Okay? And that's how I show a hole in my graph. And if I have to exaggerate it, I'll say, okay, there is my hole. So that's a way of knowing it. All right, but we only have a hole when something on the bottom and top can be canceled. All right? So we've got 2 more to look at on the back. And then we'll be all done. So number 17. Great thing about number 17 is it's just like the easy ones that we did yesterday. So vertical asymptote, x equals 2. Horizontal asymptote, y equals 0. Domain, x cannot equal 2. Range, y cannot equal 0. And there are no holes. Okay? So horizontal asymptote and vertical asymptote, I'm going to draw those in right now. There's my vertical asymptote. Here comes my horizontal asymptote. Okay? And now I'm going to put this graph in my calculator. Y equals 3 over x minus 2. Okay, looks like that. Press graph. There's my function. Okay, go to the table. I want the 2 values to the left of the left of 2 and the 2 values to the right of 2. So I've got 0, -1.5. I've got 1, -3. And then my error. And then I've got 3, 3. And I've got 4, 1.5. Okay, that's what I'm going to graph. So 0, -1.5, so 0, -1.5 is right there. 1, -3. 1, 2, 3. So it's right there. So this gets kind of close over here, and then kind of curves back out and comes down this way. All right, so something like that. Doesn't have to be perfect. 3, 3. 4, 1.5. Again, doesn't have to be perfect. We're just going to get close, and we'll draw it so it looks like the graph on our calculator. Okay? So that's number 17. Last one, number 19. And again, you should be trying these on your own, but again, we'll look at this on Monday. All right? Neither of these can be canceled. So both of these are going to be horizontal asymptotes. And we have nothing added at the end, so both these are going to be vertical asymptotes. I said that backwards. Both these will be vertical asymptotes. I have nothing added at the end, so my horizontal asymptote is y is equal to 0. So in this case, my range, or my domain, y cannot equal 0 for my range. My domain, x is not allowed to equal either of my asymptotes, which are at 1 and x equals 5. So x cannot equal 1 or 5. My wholes, I don't have any because nothing can be canceled out. Okay, so we're going to graph this. This is going to look kind of weird, and we're going to have to kind of graph all around 1 and 5. So instead of using the numbers, I'm going to use two numbers to the left of 1, -1 and 0. And then I can't use 1, so I'm going to use 2, 3, and 4. I can't use 5, so I'm going to use 6 and 7. Now I know you used a lot of numbers, but I used the two numbers to the left of below 5 and above 5, and the two numbers below 1 and above 1. So unfortunately I had to use a lot of numbers here because there were two vertical asymptotes. So I've got a vertical asymptote at 1, so I'm going to put a bunch of dots, dotted line going down there. I've got a vertical asymptote at 5, dotted line going down there. And I've got a horizontal asymptote at 0. Okay? So let's graph this. Y equals, whole numerator needs to be in parentheses, x plus 3, x plus 3 parentheses. And now here's where it gets a little weird. The whole denominator needs to be in parentheses. So I'm going to put bigger like braces. But no, I'll use parentheses. I'm just going to have to use them multiple times. So I'm going to do a parenthesis for the whole denominator and then a parenthesis for x minus 1. X minus 1, and then x minus 5. So that's parenthesis for x minus 1, x minus 5, and then one more parenthesis for the whole denominator. So that should get it all. When I press graph, you can see where I have my asymptotes. Okay? So let's look at our table. So at -1, I've got 0.167. That's actually 1/6. At 0, I've got 0.6. But you can write 0.167 if you want. It just means we're really close to 0. At 2, we've got -1.667, which is -1 2/3. At 3, we've got -1.5. And at 4, we've got -2 1/3. Again, if you use the decimals, that's fine. I'm not worried about that. At 5, we've got an error. At 6, we've got 1.8, which is 1 4/5. But again, you can use the decimal if you want. And then we've got 0.83 repeating, which is 5/6 for number 7. But again, you can use that 0.83. I don't care. Okay. So if I looked at the graph and I look at, it kind of curves through here. It's got like a little hump here, and then it curves through this one. So this one we're going to make look like a little hump. This one we're going to curve, and this one we're going to curve. Okay? So we'll start on the left. -1.16. That's really close there. 0.6. That's really close to here. So it looks like this, and that kind of shoots up there, shoots back down there. So that side's finished. Now, -2, -1 2/3. I'm sorry, +2, -1 2/3. That's like right there. +3, -1.5. That's like right there. And then +3, -2 1/3 is like right here. So this graph, you can see, is really weird. This will shoot down, and this will shoot down. Okay? And then the top right part, we've got 6 1 4/5. So that's like 6 1.8, and then that 0.83 for 7. And again, this one kind of comes down and curves around. Okay, so I know I went through this rather quickly. If you at any time need help, stop it, pause it, and come back. Okay? Hopefully you have a great weekend, and good luck.